The next question is, a company has a multi-node Windows legacy application that runs on premises. The application uses a network shared folder as a centralized configuration repository to store configuration file in XML format. The company is migrating the application to Amazon EC2 instances. As part of the migration to AWS, a developer must identify a solution that provides high availability for the repository. Which solution will meet these requirements most cost effectively? Option A. Mount an Amazon Elastic Block Store Amazon EBS volume onto one of the EC2 instances. Deploy a file system on the EBS volume. Use the host operating system to share a folder. Update the application code to read and write configuration files from the shared folder. Option B. Deploy a micro EC2 instance with an instance store volume. Use the host operating system to share a folder. Update the application code to read and write configuration file from the shared folder. Option C. Create an Amazon S3 bucket to host the repository. Migrate the existing XML file to the S3 bucket. Update the application code to use the AWS SDK to read and write configuration file from Amazon S3. Option D. Create an Amazon S3 bucket to host the repository. Migrate the existing XML file to the S3 bucket. Mount the S3 bucket to the EC2 instances as a local volume. Update the application code to read and write configuration files from the disk. The correct answer is C. The next question is, a company wants to deploy and maintain static websites on AWS. Each website's source code is hosted in one of several version control systems, including AWS Code Commit, Bitbucket, and GitHub. The company wants to implement phased releases by using deployment, staging, user acceptance testing, and production environments in the AWS cloud. Deployments to each environment must be started by code merges on the relevant Git branch. The company wants to use HTTPS for all data exchange. The company needs a solution that does not require servers to run continuously. Which solution will meet these requirements with the least operational overhead? Option A. Host each website by using AWS Amplify with a serverless backend. Clone the repository branches that correspond to each of the desired environments. Start deployments by merging code changes to a desired branch. Option B. Host each website in AWS Elastic Beanstalk with multiple environments. Use the EBCLI to link each repository branch. Integrate AWS Code Pipeline to automate deployments from version control code merges. Option C. Host each website in different Amazon S3 buckets for each environment. Configure AWS Code Pipeline to pull source code from version control. Add an AWS code build stage to copy source code to Amazon S3. Option D. Host each website on its own Amazon EC2 instance. Write a custom deployment script to bundle each website's static assets. Copy the assets to Amazon EC2. Set up a workflow to run the script when code is merged. The correct answer is A. The next question is, a company is migrating an on-premises database to Amazon RDS for MySQL. The company has read-heavy workloads. The company wants to refactor the code to achieve optimum read performance for queries. Which solution will meet the requirements with least current and future effort? Option A. Use a multi-AZ Amazon RDS deployment. Increase the number of connections that the code makes to the database, or increase the connection pool size if a connection pool is in use. Option B. Use a multi-AZ Amazon RDS deployment. Modify the code so that queries access the secondary RDS instance. Option C. Deploy Amazon RDS with one or more read replicas. Modify the application code so that queries use the URL for the read replicas. Option D. Use open source replication software to create a copy of the MySQL database on an Amazon EC2 instance. Modify the application code so that queries use the API address of the EC2 instance. The correct answer is C.